Welcome class 9. Today we are going to start with the new chapter number 8, Propagation of Sound Waves. We all know that sound is a form of energy that produces the sensation of hearing in our ears. Like light energy is responsible for the things to be visible in our eyes, similarly sound is a form of energy which produces the sensation of hearing in our ears. Sound is always produced when a body vibrates. So if a body is vibrating, then it will produce sound as it passes as the vibration passes through the medium and reaches our ears. So we can say a vibrating body is a source of sound. Now with a very simple example, let's find out how the sound is propagated through a material medium. So let's say that there is a bell jar which has an electric bell inside, and the bell jar is connected through a vacuum pump here. So when these wires are connected by a source of current, okay, then the bell will start to ring. As this jar contains some amount of air inside, the vibration produced by the electric bell passes through the air inside the jar, and the jar itself starts to pass that vibration, and it passes through the air outside the jar, and thus it reaches the ears of the observer. So as the bell starts ringing, we can hear the sound through this kind of propagation of sound waves. Now, if the vacuum pump starts to withdraw air from the jar, then the air inside the jar gets reduced slowly, and thus the sound which is getting propagated is becomes less. As the vacuum clears out or sucks all the air inside, and there is a kind of I cannot say 100%, but if there is 99% of vacuum created inside the jar, then we will see the hammer of the bell is hitting the bell, even though we cannot hear the sound. Okay, this happens because the hammer hits the bell, but the sound wave does not have any material medium to propagate the waves, and thus there will be no sound heard. Thus we can say that the air has been removed from the jar, so sound produced because of the vibrations from the bell could not travel to the wall of the jar, so we cannot hear the sound that is produced by the electric bell. So this is the demonstration by which we can prove that the sound requires a material medium for its transmission, and it cannot travel through vacuum. Thus, a material medium is necessary for the propagation of sound from one place to another. Requisites of the medium. So what are the requirements that the medium needs to have? Number one is the medium must be elastic. Okay, this means that the particles, they need to come back to their initial positions after the displacement takes place on either side. That is, the particles should be capable of vibrating in the mean position from this side to that side and again come back to the mean position. This is what the medium must be elastic means. Number two, the medium must have inertia. As we have already learned about inertia, Inertia means the capability to retain back its original position or its original state of rest or motion. So over here, the particles needs to store back their actual position, in this case their actual mechanical energy. If the particles, if they don't store their mechanical energy back to their original position, then the medium won't be having inertia, and in that case it won't be able to propagate the sound waves properly. So the medium must have inertia. Number 3 is the medium should be frictionless. If the medium is not frictionless, then there will be some loss of energy. So the medium should be frictionless so that there is no loss of energy while the propagation of sound takes place. So here we can say that sound cannot travel in vacuum through the demonstration that we have done earlier. Now let's learn about propagation of sound in a medium. Have a look over here. This is a metal strip which is vibrating from left to right and from right to left. So when a source of sound vibrates, it creates a periodic disturbance in the medium, and thus this disturbance travels in the medium in the form of waves. So as the strip moves to the right from left, it pushes these particles of air in the layers in front of it. So the particles of these air layers gets closer to each other, and thus they get compressed. So this is the compression that moves forward, as we can see. So the particles of these layers, while moving towards right, pushes and compresses the layers next to them, which then compress the next layers, and it moves on in the similar way and it moves forward. Thus the disturbance moves forward in the form of compression, and the particles of this medium gets displaced, but they do not move along with the compression. You can see these particles, let's say these are the particles in red, they are getting compressed and they get displaced, but they are not moving along with the flow of the wave. Again, as the metal strip starts moving from right to left, okay, they start to push the particles in front of it, and the particles of air near the strip starts returning back to their mean position. This is because the medium is elastic. If the medium is not elastic, then this would not have been seen. When the strip moves to the left from right, it pushes back the layers of the air near it towards its left, and thus produces a kind of space, as you can see over here. Okay, when it moves towards left, there is a kind of space which is produced, which is actually of very low pressure compared to its right side, compared to this region. So the air layers on the right of the strip expands in this region as it moves towards left. There is some kind of expansion. So this expansion is actually the rarefication of air layers. So this region of low pressure is called the rarefaction of the air particles. So in this manner, as these waves continue, okay, and the metal strip moves from right to left, the compression and rarefaction gets produced, and it continues the disturbance, and thus due to this nature, the energy is produced continuously and the wave moves in the forward direction. This wave in which the particles of the medium vibrate about their mean positions in the direction of propagation of sound is called the longitudinal wave. So this is the longitudinal wave, and thus we can say that the sound travels in air in the form of longitudinal wave. So this area where there is compression, okay, where the sound, where the air particles are getting together, and this is the portion where there is rarefaction, where the air particles are little far away from each other. So the rarefaction and compression are the two parts of the longitudinal wave, because of which the wave moves forward. Next, the characteristics of wave motion. A wave is produced by the periodic disturbance at a point in the medium. The particles of the medium vibrate about their mean positions, and energy is transferred with a constant speed from one place to the other place. So these were the main characteristics of wave motion. In the next class, we will learn about some terminologies which is related with the wave motion, and this much for today's video. Thank you.